And then you broadcast for up to 8 hours.
I guess I'll keep y'all here for that. It's about 6 hours.
Okay.
So are we ready to go?
Yeah.
My name is Brett Estrade. I work here and talk on Sphinx and things you can do with it, and how Perl can help you do things with it. Stop me at any point in time if you have questions. Has anybody ever used Sphinx before? Vaguely familiar with it? Okay. It's a full text search indexer in Daemon. So it's two tools. There's the indexer, which builds the index, and then there's the search D, which runs as a Daemon process, and you can interface with it to actually search the indexes that you've created. It's pretty easy to configure and install. It's available in on most Unix-like operating systems in all the different package repositories. So it can handle databases as the back end for the indexing. So MySQL or MariaDB, Postgres, they're natively supported. And you can, the way that you interface with it, and I'll have an example. Basically, you just give it a query, an SQL query, and it connects to the database server with the credentials you give it, just like you would do manually, and it issues this query. And it can be any kind of SQL that you would normally send. So you can, it's actually nice to use if you want to create a read-only front end for expensive joins. The other data source is just a generic way to get generic data into the index. Is it's an XML format called XML Pipe 2, and it's just if you have whatever data, you can build a transformation scripts to take that data, output this XML format, and then the indexer can read in this data, and you've got whatever your arbitrary data is indexed. So it supports, for connecting to the daemon, there's this very simplified native protocol, and then there's also, it can support, basically replace MySQL as a daemon to receive queries. And it's a subset of SQL that you can use, and they call it SphinxQL. And it actually even supports like insert, update, these sorts of things. And when you issue those through the MySQL protocol to the search D, you can actually modify the index that's inside of that's running. So you can kind of dynamically update it if you want, or modify it. This is an example of a fairly simplified configuration file. The top part here, that's where you're setting up the backend data source for the indexer. This one is using MySQL. So type is just MySQL, SQL host, IP address, user, pass, and then database. And then there's the query right here. And this is just an example. I'm gonna come back to this query because point something out about this CRC32 thing. So when you issue a query or any type of entry that is being indexed, it requires a unique ID. So normally when it's using MySQL as a backend data source, it expects the ID field to be returned for each record. And then here I'm just saying I want whatever, the title column, and then a Unix timestamp of start time. So my main use case here is indexing eBay data. So basically getting a ton of eBay data and indexing it for searching. So that's where we get the title. The ID typically, and this is all like something that I have running that I use on the side. But the ID, I use the an eBay item number because those are unique. So that's what's getting returned there. Now, Sphinx has a concept of fields and then attributes. Fields, the field is that full text thing that is going to be searched. So in my example here, it's simply the title of the eBay item. So that's just one line of stuff. You can have lots of data in there. The attributes are used for filtering. So if you want to, before you issue your full text query over whatever's in the field, and you want to filter out, you want to get a small set of data that gets filtered out based on some attributes, then you would use whatever attributes you've defined. So in this case, both of the attributes I've defined are integers. The first one is just a Unix timestamp, the start time of the auction, and then the second one is the CRC digest of a string. So it's just an integer also, and that comes into play later on. I'll show you. Any questions so far? So basically, what happens when you run the indexer? This is the information it uses to connect to the backend data, and Sphinx handles this natively. This part, this is where you create the actual named index that search D is going to read in. Or so that it basically partitions the data by index, and this is where you define what that index is. What this section is telling me is I'm creating an index, and it's called eBay_completed. The source is src1, which was defined up here. So I'm using that MySQL database and select statement as my source data. And then this other stuff is just, it doesn't really matter, it's just attributes. But I did want to point out the min word length and stop words. You can use, this is used for if you wanted Sphinx to give you like a frequency analysis of the keywords of the data that you're indexing. And you can issue some commands through the indexer. While it's generating the index, it will keep a frequency count of the keywords that it finds. And you can output that information and do things with it. This last section right here, this is actually configuring the daemon. The important thing here is just this listen option here. It just issues, or it just sets up the IP address and the port that you want to listen to. In order to, I don't have an example here, but I can maybe pull up an example. Because I don't use the MySQL protocol interface for searching, but you can set up a listener that listens for MySQL by appending a colon and then the string MySQL41 that defines the protocol that it'll listen to. So effectively, what you can, if you just need a read-only front end to whatever, you don't even have to have MySQL installed on your machine. You just index some data using Sphinx, and then you can set up the listener to talk MySQL41, and you can interface with it with any MySQL client. So it's pretty slick in that way. This is a client. It's a very simple client. It's in Perl. The standard Perl client is just Sphinx search, and what you need to do to set it up, you just create a new instance. You set server here. There's no concept of clustering, so you just set one IP address, port. And then the set limits. This is basically a starting point and an offset. It just says how many, basically what snapshot of results you want. So here I'm just saying start at the very beginning and just give me one result, because that's all we need for this example. So here, this is where I get my results. This set match mode. There's a ton of different match modes, and essentially what I'm using here, it's this SPH match Boolean. It's it supports a Boolean expression for searching. So it can be like keyword 1 and keyword 2, and then you can use parentheses to nest. It's a logical expression of keywords, so it's pretty handy. The query, so that sets the match mode. This query here, I'm just using an empty string. If I wanted to put a keyword or a specific, this is where I would put my Boolean expression basically. That it's an empty string will tell Sphinx just to return all results. So however it's getting ordered, I just want the very first result based on the set limits. And then this dollar indexes, it can accept a comma delimited string of your native indexes. And in this example, I'm just using the eBay completed. But if I set up multiple indexes, I would just create a comma delimited set of those indexes. So again, this is how you would partition data within Sphinx. Questions?
Will total found be 1? Is it limited to 1, or the total number of
Total found is the absolute total number that match this Boolean expression. And I'm going to show you the data structure that gets returned.
If you come up the slide.
Mm-hmm.
I see the seamless rotate, so this has a concept of it's constantly crawling, and then when it gets new crawl results, it just automatically goes into effect.
No. Basically, what happens is when you run the indexer, which is a separate program, you can give it an option --rotate, and it'll find the PID of the running search D process and then kick it, and then it'll restart using the new indexes.
So it has to restart them.
Yes.
Gotcha.
And I can show you an example of it restarting.
Yeah.
Okay. Good questions. Okay, this is the search results. This is the entire thing that gets returned in the results hash. The match is this is the one match here. Okay, so this is all the information that I've pulled out for the one item. The total found is this number. So there's almost 2,225,000 items in this. So that's quite a few. I mean, it's not an insane amount, but it's a lot. The fields here is title, so that's what I'm doing my text searching. And these are the attributes. This is the so the PCAT is the primary category, and the CRC32 is just the integer form of that. That's just start time, title. These are, I don't know what these numbers are for, but they're not the values of these. Okay. So some common use cases. I think this lends to what you were talking about, Todd. When you've got the daemon running, you're going to want to update it sometimes. So a lot of times, in my case, this is what I do. I just rebuild the indexes from scratch. Even though there's over 2 million records, it happens pretty quickly. Some people will, I mean, they've got instances of Sphinx that are running, that are storing billions of documents that get searched over. So you're probably not going to want to restart that each time. So they've got concepts where you can do incremental updates to the index. And I've never messed with that, but it's called delta indexes. So basically, it's able to track. You create an index only on the new data or the data that's changed, and you're able to create some kind of a delta file. So it's effectively able to just straight up, update only what needs to be updated in the running daemon. But I've never played with that. Let's see. For searching, I mentioned before, since it can listen on the same, talk the same protocol as MySQL, there's the okay. So a lot of times, what people will do with this data is they'll run a search on it, and they'll take these IDs that get returned, and those IDs will be primary keys in a much, in the actual, say, MySQL database. And if you're putting a read-only front end in front of an expensive join, you're basically reading cache data very, very fast. You're getting the IDs that match that join based on your search criteria, and then you'll go and make a pretty simple query to the database to get more information. That's what you would tend to do if you're keying if you're pulling in matches that have a lot of related data. In my case, I'm not doing that. So all the data that I need is already in Sphinx. And the only thing I'm using the database for is just to keep persistent data that I want to archive. Okay, so I'm gonna talk about some real life examples, and these are all things that I can show examples of what I'm doing for. So indexing MariaDB. I've got a database full of basically completed eBay auctions, and I use Sphinx to suck in all of those results. So there's over 2 million of them, and it indexes. And then so Sphinx provides a front end search interface so that if somebody, I've got just a basic web search interface. When you search over that interface, instead of hitting the database every time, it's just hitting Sphinx, and that's pretty much exactly what Sphinx is for. Filtering on strings is something that is not as straightforward as you think it would be in Sphinx or in some sort of application like Sphinx. But basically, if you've got a string attribute and you wanted to only search fields that had that string attribute, you can't do that directly just by specifying a string. You have to turn that string into an integer. And you do that using the CRC32 method. The next one is going to be creating sources with Sphinx XML Pipe 2. So if you're using non-relational database, if you want to index non-relational database things, or in my case, I don't even want to use a database for this application, so I just don't. And then there's the other thing I'm going to show is the dynamic configuration with this module Sphinx config builder, which is something I wrote so that I could actually manage a set of many changing indexes, because the manually having to update the configuration file gets to be a pain. Okay, so what I was going to do here, I'm going to run. This is the output, but basically I was going to run the indexer, and I'll let's see. All right. So this is a static configuration file, and this is the query that I'm indexing, and these are actually all of the fields that I'm indexing here. So that the example in here was just a condensed version. But when I run the indexer, it'll take that because I've set up a source, I've named an index, and I've got the search deconfiguration. So the indexer will take the first two sections. This actually takes about maybe a minute. And what it's doing right now is it's actually pulling all of that data from the MySQL database, or the Maria database. And it's going pretty fast. This is not a souped-up machine. It's a Dell PowerEdge 1950 with 4 cores on it. And MariaDB is. And it moves pretty fast. And what you'll notice here also is that I think it's finished now. This number here, that's the size of the index. So the index for over 2 million of these records is only 124 megabytes, which I like. When you run search D and it loads the index, it loads everything into memory. So I've actually been impressed with how little memory the indexes take up.
So it's a keyword index?
I don't know. It's a very optimized index. I have no idea how it works. But that's kind of like their special sauce. Obviously, it's open source, and you can look into it. But yeah, I have no idea. But it works on a concept where you have the fields, which are indexed, and then you can associate attributes with the fields.
Are these fields database fields?
Yes, in my case, yes. I mean, you can essentially, the way I'm using it is I've got one field that I'm doing the full text search over, and then attached to that one field I've got attributes. The attributes are used to basically, like in an SQL statement, you have a where clause to kind of trim down your search area. That's what the attributes are for. You can filter out you can reduce the search area using the attributes, and then using your keyword or your Boolean expression you then use the Boolean expression or keywords to find that field within that small subset that you filter down to and get the matching results.
So is this any table with a keyword, all tables?
Any arbitrary, yeah, I mean you can have arbitrary SQL, so you could have like a super complex, really heavy join happening, and then it'll index that data, and then once it's indexed, it's in search D. You no longer have to touch the database itself until you want to update that chunk of data again, and then after that, it's just the cost of searching Sphinx, which is pretty low.
Are all fields automatically attributes as well?
No. Okay, this right here. So in the command here is this -- rotate, and then once it was finished reading or creating the indexes and writing all the files, it just sent a HUP signal to the search D and restarted it and then reloaded. Okay, so that's that. Now, filtering on a string, as I said, it's a kind of a pain in the butt. Basically, what you have to do, you have to create an attribute of whatever string or whatever field that you're going to be filtering, say in the database. Create an integer that, so the attribute becomes the integer. And what I've done, the example here, this SQL statement, my SQL has a CRC32 function, and it just converts that to an integer using the CRC32 algorithm, which is a hashing algorithm, and that gets saved as this pcat CRC32, which is primary category and CRC32.
Okay, so the results of the query are a series of numbers.
It's an integer,
And those
yeah.
numbers are what's actually indexed.
Yes, exactly. Well, those aren't indexed. Those are attached to the indexed data.
Oh.
That becomes an attribute. Just like I also in here in this example, I have in this example I have start time just as a Unix timestamp.
Right, but let's say primary category, I'm going to assume that's a string, right?
Yes. In the database, that's a string.
Okay, but I don't see that you're actually querying primary category in its normal sense. Doesn't that mean you wouldn't?
I'm not in here in the real life example. I do carry that in there, and the reason is
Because you have to tie the two together.
right. You have to tie the two together, but I can't filter on the string version of the primary category.
Right.
However, when I get the search results back, I want access to that information. So I'm attaching the string version of primary category, but in order to filter over it, I have to attach another corresponding CRC32 version of that to each entry.
And so I suppose you probably don't know a lot about the collision issues.
No, and I haven't done any studies. I haven't really even looked into CRC32 much.
CRC32 is collision.
That was a recent excitement. One was one Perl to use a CRC32.
Yeah, I saw that. That's what when I was doing this, that's what I thought about. I probably should learn more about it, but anyway, so that's how you do it, and that's just the standard thing you do in Sphinx. I mean, it's a very common problem. You know, I was not the first person to type that how to filter by strings, attributes by strings in Sphinx in Google, because it auto-completed pretty quickly, and then I started seeing the CRC32 everywhere. Okay, yeah, so MySQL has a CRC32 function, which is nice and convenient. The Perl module I used to implement this was string CRC32, There's a digest CRC32, I think, that I tried. For some reason, I probably was using it incorrectly, but I couldn't get them to match. But I did find the string CRC32 matching. So. And then once you do that, you set the filter. So just like there was the set, there's all these different modes and settings you can make when you're interfacing with Sphinx. In order to set the, in order to filter by something, an attribute by something, you use this set filter method. And in this case, I'm setting, I want it to filter on, well, this should be pcat CRC32, but I want to filter pcat CRC32 by the value I compute. So this is within a CGI script. I get this parameter of primary category, which is a string, and it corresponds to the string that's in the database, not the integer. And then here I pull it out. The CRC32 variable here just gets the value returned by invoking the CRC32 method on that string, the category string itself. And then that's when I, right after that, I set the filter. So you do this before you would invoke your search. You just say, I want to filter results. I want the PC or pcat CRC32 attribute to contain this value, or in this case, it could be a series of values. So if you wanted to search it, you wanted to limit your search set over multiple integer representations of the primary category, you could do that. Up here, this is just a flashback to the configuration file where I'm setting an attribute. It's just an unsigned integer. Well, this is start time, and then this is the same deal with the primary category CRC32. So, okay, now transforming things to XML pipe 2. It's like I said, it's a generic format. So in the world of, I guess, data warehousing, there's the ETL, the extract, transform, load concept, where you can take data in some format, whatever format you have, and you have scripts that extract the data you want, and then they transform it into the format that you want, and then you load it into your system. XML pipe 2 is what you want your data to be transformed into. Now, as far as writing the extract and transform scripts, you obviously have to write whatever you have to extract the data you want, or to get the data you want. But the transformation is facilitated pretty well by this Perl module, which is Sphinx XML Pipe 2. And really, it just allows you to build up a giant hash reference that then gets converted into the XML Pipe 2 format. So it's pretty straightforward. I'm not saying this is the best module in the world. That's the Perl module to use for this. This is an example of what XML Pipe 2 format looks like. This top section, so it's just a typical XML document. The schema portion right here, that's the end thing. These are all the attributes. So this is just the namespace tag attribute, ATTR, and then up here, that's where you define your field. So basically, whereas it's in the configuration file, when you're dealing with MySQL, you're using the configuration keywords. This is communicating the same information, this top portion, that the top portion in your configuration file communicates. And then after that is just all of your data. The one thing I don't like is that I could not find a way to allow a single index to support multiple XML documents like this. So if you wanted, if you have your data set and you wanted to index it under the same, same data, the index name, all of your data has to be in this XML file. So that's not really a huge problem. I mean, I haven't run into any speed issues because I haven't I have a lot of indexes, and they're moderately sized. I don't have like one that's huge. So I haven't really run into any problems.
So do you have to generate a new file every time you want to index?
Yes.
Or can you do a delta file?
I don't know. That's a good question. No, I generate new files every time.
Right.
But maybe I just haven't looked. That's a good question. So this section here, this is a configuration file. So the XML pipe 2 format kind of takes care of that first portion of your of the configuration file where you're defining your backend data source. This is how you point Sphinx or the indexer to that data source, and you're using the same source section. But here it's pretty simple. It's just type, and it's going to be XML pipe. Now this XML pipe command, it can be any shell command. So all I'm doing here is it just needs the contents of that XML file somehow. It doesn't know necessarily how to go in and open the file and read it, but whatever this command is, it'll take the standard output of that and then suck it in. So here I'm just catting the file, and this is actually very fast. It works really, really well. And then so that's the source section, and then there's the index section here. Just like the index section before, I've just got a lot fewer fields. The source is just pointing to this top source section. This path is just where it dumps all of its index files. And then the character set here is UTF-8. Why patches? I've been, because I collect Boy Scout patches.
And it's your project. It doesn't have
Yeah,
anything to do with
and
indexing,
I don't, like, there's a lot of people who sell it on eBay, and I don't feel like selling it on eBay, but I want to keep track of all of that data.
Yeah, I just thought it might have something to do with the indexes, because you got patches attached to the indexes.
It is a source of confusion, but no, different kind of stuff. But anyway, it's. But that's my main. That's what the kind of data that I collect on eBay. Okay, so I've actually got two applications. I've got one application where I save completed items, and I've got another application where I essentially cache active auctions. Now, the one where I cache active auctions, it's pretty much always changing. So I don't want to store that data. I'll get it on the back end when it completes. So I just use Sphinx directly. I don't use MySQL or MariaDB with it. So
How do you have access to the database?
there's a developer API, and like there's not that many items on eBay. I mean, there's a lot, but there's not compared to other things. So I never really go over the request limit.
So you're actually requesting the full list of some search every so often?
Mm-hmm. It's actually many searches that I'm doing.
And they don't give you a delta, they give you the full thing?
Oh, yeah.
Every time you query?
Yeah.
Wow.
And it's all in XML?
It's XML, yeah.
I've got some Amazon stuff, and I hate that.
Yeah. Yeah, I don't know. I think they have some more modern APIs, but this data is XML for sure. Okay, so let's see. Oh yeah, so I'm using a lot of different indexes, and at one point I probably have over close to this now, like 250 different indexes. And I've actually reached the limit of indexes on Sphinx, which is memory bound. But again, I don't have a huge machine, so I'm sure I could go way further on a different machine. Now these data partitions do change slowly over time because I track stores, I'll track specific searches, I can track specific categories. So sometimes categories go away, sometimes stores go away. So, like I said, it's a giant pain in the butt to maintain a static configuration file for this. So we already know Sphinx partitions data by indexes. the problem is that each index uses its own data file, so I'm maintaining like a ton of sets of these XML files, which that's not the problem. The challenge is how do I manage all of, generating or maintaining this configuration file that has all of these indexes. And this is the really cool part about Sphinx, or at least my favorite part about Sphinx. But the configuration file can be a script, and that's not very common, I would think. So what I do is I basically just have a Perl script that emits a configuration file, and it can change every time. So it's not, I don't maintain a static configuration file. I've got all these variables that are changing, so each time that I re-index, it pulls in the proper, whatever the proper configuration should be.
How does it know that's a config file or an executable script?
Good question. I don't know, but this is set to be executable, so I don't know if it checks permissions, or if it does a cat and then looks at the shebang at the top. I actually don't know that part. Yeah. This -- all, it just says, index all of the sources that are in there. You can specify specific sources if you don't want to do everything. All right, so I wrote this module. It's Sphinx Config Builder because there wasn't anything that suited my needs at the time. It's pretty low level. It really just builds up each section by pushing the configuration keyword and the value as a hash reference onto an array, and then when it's finished building each of those sections, it just outputs the like the source section or the indexer section. Let's see. It's got all A's on the CPAN testers site. It's all green, which is nice because I packaged it up all nice. I have a unit test and all of that stuff, but I don't know if anybody's using it, but I haven't heard any complaints.
At least you passed the test.
Yeah. Okay, so the XML, that should be XML pipe too. The data file should already exist. It iterates over an array of indexes to build, and in order to track all of the indexes, I have yet another configuration file. So that's the last one. It creates source entries for each index based on the XML data that it's expecting, the file path, and then it creates the source entries, and then it creates the index entries that are tied into the source. All right. This was the inspiration of my title. So, okay. Let's see. So this is the. Okay, so the script that I wrote, the dynamic configuration file here. Oops. I must have it already open. All right, yeah, I'll stop looking. Okay. So this here on the right-hand side is, on the left-hand side, I'm sorry, that's a configuration file, and it's just an INI file, and it just lists. So I've got all the basic searches, and then I've got categories that I search, and then within each category I've got stores that I search. This is the configuration, the dynamic configuration file itself. It uses the Sphinx Config Builder module, and literally all I do is iterate over all of the categories that were in that configuration file that you see. When I want to create a new source section, that's this line right here. So I just create a new, it's Sphinx config entry source reference, and then I create an index section, and then I set the name. So I set different attributes, set the name. This KV push, it's just a configuration key value pair that I push, and then when I print out the source as a string, it just prints out like what a source block would look like in the configuration file. And I do the same thing for index, so these things get generated in pairs. And then I just do that for every index. And I named the indexes in such a way that I can, based on the index name, I know where to look for the XML file, so I can generate the file name from that. And then down here, let's see. So I've got the, oh yeah, okay. So there's the source section and then the index section. So I have many of those pairs. And then at the bottom, you've got a section for the indexer itself, which is this line right here. And here I'm just setting a memory limit of 1 gigabyte. It was set at like 128 megabytes, which is way too low. Which is why I think that's the default. But so I'm explicitly saying, you know, when you're indexing, use up to a gigabyte. And then I've got the search D section where I can set all the different parameters that we saw. So this will output the section with the listener IP address and all of that stuff. So when I run it, it's pretty fast. And then it'll go through. You can see, like, I mean, there's just a ton of indexes in here. Okay, so now we finally got to the bottom. This is the indexer section that I created, and then this is the search D section. And the reason why I wanted to jump down here is because it has that example where if you want to set up a listener, you can set up multiple listeners on different ports. This listener here is just listed on 9312, just using the typical Sphinx protocol. And then this one is set up to listen for MySQL protocol. And okay, almost done. So Sphinx can be used for a ton of things, literally. Like, if you're familiar with data warehousing, it can be used. It can be used to kind of build a poor man's data warehouse by using some extract, transform, and load scripts. Well, the load part happens during the indexing. So, but you can literally index anything you want, as long as each thing that you want to search over has a unique ID. And there's lots of clients. The Perl client's really nice. I have never had a problem with it, and it's easy to build. It's very actively maintained, and there's a really good forum. That, I mean, I've never had to post in there because it's usually the question I need to find out is answered. So, very good. That's it. Questions?
I have a question about the first slide.
This one?
Well, I guess not. You were showing a query where you were searching for keywords. It's the third or fourth slide.
Oh, okay. The maybe this right here.
Yeah, and then you looked at the results.
Yes.
So what had you searched for?
I sent it. I gave it an empty string, and it interprets that as you want everything.
Okay, but it's searching for precise strings.
So the match mode here is Boolean. So I can put in a keyword, and if it finds that anywhere in the string, it'll mark it as a result.
So it's okay. So it's not just doing a CRC32 on the full string and nothing else.
That CRC32 is it's just like a where clause in SQL. It's just to get the smaller set of data to search over. So that's an attribute.
But that's just one index. It's also making a keyword index on top of that.
I would imagine so. Yeah, because there's the attributes that get filtered. Yeah, so that's one index, and then it has to facilitate the full text searching. And in this case, in the Boolean match mode, you can send it that Boolean expression of keywords. It'll, it has to. I'm sure that's set up specifically to make that optimal.
So it seems like the big advantage here over databases is keyword searching.
Full text searching.
Yeah.
And if you've got some really heavy joins that are happening, that for whatever reason your database design just forces you into that corner, then and you don't have to have absolute real-time results.
Yeah.
You can use this as more or less the read-only cache of the results of that join.
Gotcha.
So you could really even use Sphinx in a like an offline processing type of situation where there's some applications where they have to be responsive right away, so you find yourself having to go to a database. If you have like a report system, things like that, where the responses don't have to be handled immediately, you can build up your data set using some complex joins, get you interesting information, and then, assuming it's offline, it's not super time sensitive, you can then use the Sphinx as the source of your final report, which is why I bring up the data warehousing thing. And Sphinx is just one of many different, search things. I know there's Elasticsearch and what is Lucene? Is that a different one?
I don't remember what Koha used. I looked it up. But
Solar's one. So I know. A lot of people like Elasticsearch, but it's different. I mean, that takes unstructured JSON and then lets you do some searches for it. But this is one of the original, and it's still really useful.
And the actual client is compiled C code? Or sorry, the server?
The server is compiled, yeah, C code. The client just, I think it may be just pure Perl. I need to look. But it's a super simple protocol, just like, say Redis has, where you just connect and you just give it a series. It expects a series of numbers and whatever. So I haven't tried, but you can probably connect over Telnet with Sphinx and talk to it.
If nothing else, for MySQL.
Yeah. Yeah, I mean, you can fire up your MySQL client, and if it's listening for that protocol, it'll interface. I mean, you'll think that you're talking to a database.
Can you write to this database?
You can. The subset of SQL it accepts, it supports inserts, updates, but if you're modifying the data. So it's not, if you reload your indexes, you're going to get rid of all of your changes.
So I can't insert rows either. Then I can
you can insert rows. Yeah, you can.
I don't go all the way back to the original source.
No. Mm-hmm. Yeah.
Is there a way to persist your index and then reconstitute it?
The indexes are saved. So when you run indexer, it writes it to files. And then when searchd starts or restarts, it just reads in everything from disk.
I saw there was an option there that said load from disk. Not load from disk on startup. It was.
Where was that?
Configuration. That's where I was asking about the.
Right here.
Yeah. Pre-open indexes.
Wait, where? Bottom?
Yeah, right there. Oh.
Oh, pre-open indexes. I don't know.
If you don't set that, it waits until first request.
Right.
That makes sense.
Or only on the.
Like a lazy loading.
That would lower your memory requirements.
I guess you could have one daemon watching a whole slew of different indexes.
Yeah, you just need to start it up with the with this configuration file or whatever configuration file. So you define the indexes and do the -- all.
Well, you were saying your 250 limit. I wonder if you could exceed that if you didn't pre-open the indexes.
I'll try that. I would get these weird issues, and this was actually not even on this machine. It was a PowerEdge 1750, which is 32-bit and pretty old, but I still had used some of those. And the indexer was set to use 128 megabytes of RAM, and I was pushing this many indexes. But then I increased it on there, and then shortly thereafter I moved over to the other machine, and I haven't seen any problems since. So I think you're probably right. Definitely related to memory. So that's all I got. Any more questions? All right.
Well, thank you.
Do I need to gracefully exit from the? Or actually, I just unshare, right?
So I don't lose that.
Uh-oh.
What do you understand about pre-open indexes, the docs say? So whether